On solving equations, we'll have only 4 questions on the test itself. So let's take a look through each of these to make sure we know how to solve them. So this first one, we want to isolate the fraction because there's just one of them. We don't need to find a common denominator. So I'm going to start by subtracting the 3 from both sides and then multiplying both sides by 2 to cancel out that 2 on the denominator. So then I get 4x plus 5 is equal to 8. And that's a 2-step equation where we can solve. So we subtract the 5, get 4x is equal to 3, and then divide by 4, and x is equal to 3/4 or 0.75. Personally, I do prefer fractions, but if you want to write it as a decimal, that's totally fine too. For the second problem, I need to get a common denominator. I see that I've got a 5 on this side, but not on the left, so I need to add a 5. If I do it to the bottom, I need to do it to the top. So both numerator and denominator need a 5x. This last one as well needs to be 5x on the bottom as well. So I need to multiply both top and bottom by 5x to get that common denominator. Now I can rewrite everything as 5 over 5x is equal to 6 over 5x plus 5x over 5x, or just multiply both sides by 5x. Either way, you'll get the same answer of 5 is equal to 6 plus 5x, and then we can just subtract the 6 from both sides, get -1 is equal to 5x, and divide by 5 to get -1/5 is equal to x, or we could write it as a decimal, -0.2. For part C, common denominator again, I see an x over there, so I need to add an x to this one and to this one, always with multiplication. And in order to make a 2 and a 3 have a common denominator, I need to get a 6 on all of them. So this needs to be multiplied by 3 to make it into a 6. And this needs to be multiplied by 6, almost wrote the 3, and this one just by 2 to make it into a 6. So now that all of these have a common denominator of 6x, I can distribute that 3x to both terms to get 3x squared minus 9x. And then plus 18 over 6x is equal to 2x squared over 6x. And now I can cancel out all those denominators and get 3x squared minus 9x plus 18 is equal to 2x squared. Subtracting that 2x squared because it's a quadratic, we want to move all terms to one side. We get x squared minus 9x plus 18 is equal to 0. And then when I do the box and diamond, I place my x squared in the top left, 18 in the bottom. That's going to be 18 on top, -9 on bottom, so -6 and -3. And so the factors, I'm running out of space, so x minus 3, x minus 6. Zero product property means that x minus 3 can equal 0, x minus 6 can equal 0, so x is +3 or +6. We just want to make sure that neither of these are 0 because then that would make the denominators equal to a 0, so we don't want that. And then next up, we've got the radical, so I need to subtract the 19 from both sides. Oopsies. And I get 3 times 2x minus 5 is equal to -12. Divide both sides by 3. And I get the square root of 2x minus 5 equal to -4. Now this is a good place to stop because I know that the square root can never equal a negative number. When I have a positive square root, it's always a positive number. So right away, I can see that this is no solution just from that point. Or I could write the little circle with a line through it. But let's say, which often happens on a test, we kept on going. So that would mean that I would square both sides and get the 2x minus 5 equal to 16, adding the 5. I get 2x is 21, and dividing by 2, I get 10.5. So it looks like we got a solution, but when I go back to check, because anytime we have a square root equation, a radical equation, we always need to check with the original. So 2 times 10.5 minus 5. Plus 19, we want to see, is that equal to 7? And if it is, then it's the solution. So when I simplify this down inside the radical, I'm going to get 16 Oh, not minus 5. That was inside. So plus 19. I still want to see if that's equal to 7. 3 times 4 is 12. Plus 19 is definitely not 7. That would be, what would that be? 12 plus 19 is 31, which is not equal to 7, which is enough to show that that is no solution because I didn't have any other values for x. Whereas this one, when we add the 2 to both sides, square root of x plus 4 is equal to x plus 2. So common. Students think they know better than Ms. Hellier. Haha, not true. I know everything. Just kidding. I make mistakes all the time. But they like to think it's x squared plus 4, but we know that we have to use the box method. And that'll get us x plus 4 is equal to x squared plus 4x when we add these two together plus 4. And then we can subtract the x and the 4. Oops. So I get 0 is equal to x squared plus 3x. Now, there's two ways to go about this. Personally, I like to look at the greatest common factor because that would just be x times x plus 3. So personally, I would just look at this and see there's an x in common in both of them. Let me take that out. So that'll just be x times x plus 3, and then I can just solve from there, get the x is equal to 0 as one of the factors, and x is equal to negative 3 as the other factor. However, some students don't see this. They jump right into the diamond. There's nothing being added to the end, so that would be a 0 on the top, 3 on the bottom. That would be 0 and 3. And then when they jump into the box, they'll still get the same answer because it's x squared and 0, 0x and 3x. So that'll be x times x, which would make that a 3 and a 0. So x plus 0 is just x. And then x plus 3 has the other factor. So either way, you'll get the same answer. It's just a little faster to look for greatest common factors first. And then we can check. So back at the original, I have root, check. I have root x plus 4, so that's 0 plus 4 minus 2. Is that equal to 0? Yes, because square root of 4 minus 2 is equal to 0. So that's looking good. But when I look at the negative 3 plus 4 minus 2, is that equal to negative 3? No, because the square root of 1 minus 2 is definitely not equal to negative 3. Therefore, this is the extraneous solution. And then this one, we add the 3 to isolate the absolute value, 3, not 6. I get 9 is equal to 3 times the absolute value of 7x minus 4. And then dividing by 3 to isolate it still, I get 3 is equal to absolute value of 7x plus 4. Now, those absolute values could be either positive or negative, so this is where I would sneak in the plus or minus 3, and we solve it from there. So I can have a positive 3 is equal to 7x minus 4, or I could have a negative 3 is equal to 7x minus 4. I've changed it to a plus, though, up there. Why did I do that? And so we add the 4 to both sides, get 7 is equal to 7x, and divide by the 7 to get 1 is equal to x. And then adding the 4 to both sides, I get 1 is equal to 7x. Dividing by 7, I get 1 over 7 is equal to x. So those are my two solutions. I'm going to make a different video for the other objective.